Unit 6.3 is using congruent triangles. We begin with a definition, the 46th definition of the text so far, a line perpendicular to a plane. A line perpendicular to a plane. For a line to be perpendicular to a plane, the line must be perpendicular to all of the lines in the plane that pass through the point of intersection. Now, let me try to create for you a visual of something that would not be. It could be that we had a line, and it's all going to kind of look the same from your own visual perspective, but it could be that you had a line that hit that plane, and to the right, it was 90 degrees, but out front, it was kind of leaning backwards instead of leaning forward, and that would be an obtuse angle there. So, you could stick a pencil to a piece of paper and you could pull it towards you. You could move it back from you. You could move it to the left, to the right. And so you could actually have a right angle to the right, but an obtuse angle out front. And if you notice, when it's perpendicular, then it's 90 degree all the way around. So if that was a piece of paper, that plane, and it was parallel to the floor, then the pencil would have to be sticking straight up and down through the paper so that it was 90 all the way around. You might think about, if you look at a wall in a room, if there's a uh, corner where you see a segment where the floor goes to the ceiling, then we could call that segment that joins the floor to the ceiling in the corner of the wall a line parallel to the plane of the floor, because it's 90 down the one wall and it's 90 down the other wall, so it would be 90 everywhere that wall hits the floor, that little seam in the wall. Okay. A line perpendicular to a plane. The line must be perpendicular to all of the lines in the plane that pass through the point of intersection. Now, what we're going to look at here is something that we've alluded to already in our work, and that is ways to prove that two segments or two angles are equal. Now, we've already learned ways to prove that two segments are equal, things like definition of a midpoint, definition of the bisector of a segment. If two sides of a triangle or two angles of a triangle are equal, then the sides opposite those equal angles are equal. Things like that. We've already learned several things that resulted in two equal segments. We've got lots of things that result in two equal angles, like vertical angles are equal, uh, addition, subtraction, multiplication, division, substitution, transitive, those things apply to both. And then we have things like alternate interior angles are equal, corresponding angles are equal, and things like that. If two angles of one triangle equal two angles of another, then the third angles are equal. Another way, though, to prove that two segments or two angles are equal is to prove that the triangles that they're corresponding parts of are congruent. So a way to prove that two segments or two angles are equal is first to identify two triangles in which those two segments or those two angles are corresponding parts. Prove that those two triangles are congruent by one of the methods we've learned so far, side, 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 or angle, side, angle. And then once you've proved that the triangles are congruent, you then could say that those two parts are equal, and the reason we use is corresponding parts of congruent triangles are equal. And we've alluded to that already. Again, as we said in the homework before, we kind of like to try to discover things ahead of time if we can, and then make a rule about it. And so let's look at this example here. We know that these two triangles are congruent by angle, side, angle. We have angle equal to angle, very next side equal very next side, very next angle equal very next angle, or as we would say it officially, two angles and the included side of one triangle equal two angles and the included side of another. Therefore, the triangles are congruent by angle, side, angle. Now, don't forget, when we name the congruency, we must name corresponding parts in order. Angle A had one arc, D has one arc, so we know that A must go to D. So if A was named first, then D is named first. B is opposite this side that was equal to this side. So the sides that are opposite, the angles that are opposite, the sides that go together would be the angles that go together. So angle B would go to angle E. And then the C had the two arcs and the F had the two arcs, and so we know that C and F go together. Whoops, so that's an F at the end of that one. Okay? So we named the congruency by naming corresponding parts in order. Now, what we were given in the to prove it with was this angle, side, and angle. And over here we were given this angle, side, and angle. Now that we know that they are congruent by angle, side, angle, we can say that all of the other corresponding parts are equal. So we now can say that angle B is equal to angle E now that we know they're congruent. We now can say that side AB, and if we call this AB, we got to go and see how we name that one. AB would go to DE. So we can say that that pair of corresponding parts are equal. And then we got BC over here that wasn't a part of the angle side angle, so we can say BC, last two letters, is a part of its corresponding side EF. And the reason is corresponding parts of congruent triangles are equal. Corresponding parts of congruent triangles equal. That's an S in that little triangle. What that is right there. I just abbreviate triangles with that instead of writing TRIANGLES, triangles. So we're just trying to make it where we can get it on the line. Okay, any questions on that? Now, all we have is a side of one equals side of another and an angle. Whoops. A side of one is equal to a side of another. And an angle of one is equal to an angle of another. We've got a side and an angle. So that either needs to turn into side angle side or angle side angle. So we look for anything else we can conclude, and we know that DB of the triangle on the left is equal to itself DB of the triangle on the right by reflexive property. So that gives us another side equals side. And so it finishes up with side angle side. What we have is two sides and the included angle equal two sides and the included angle. So these are congruent side angle side. Now, angle A is opposite BD, and angle C is opposite BD. BD was equal to itself BD. So A and C have to go in the same position, both first. We've got the one arc up there saying that B of the left one and B of the right one are the same, so the B goes in the middle for both. And then D, we can see, would be the same. Now, we know that that's going to be 90 degrees because of the isosceles triangle theorem. We've got the sector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. The isosceles triangle theorem just basically is going to show up a whole lot, so you just kind of get used to it. So we basically could make the following conclusions at the bottom. We can make the conclusions at the bottom for more reasons other than corresponding parts of congruent triangles are equal. We do know they're congruent, so we can say that angle A is equal to angle C because corresponding parts of congruent triangles are equal. But we could have also said angle A is equal to angle C because in that whole big triangle, angles opposite equal sides are equal because of the isosceles triangle rule, see? We could say because these triangles are congruent that angle ABD is equal to angle BDC because corresponding parts of congruent triangles are equal. But we could also say they're equal because of the isosceles triangle theorem, which says if we have two out of the four things marked, we can automatically conclude that the other two are true, and the other two were that it's perpendicular to the base at its midpoint. So we could conclude this by the isosceles triangle theorem. We could also conclude that AD is equal to CD by the isosceles triangle theorem, but we could also reach all of those conclusions by corresponding parts of congruent triangles are equal. Okay. Notice here that I named that CD because it's A first, D second, C first, D second. We could not have properly called that CD, even though we could not have properly called that DC, even though DC is the same segment. We must name corresponding parts in order when we name congruent parts. So since we're identifying congruent parts, corresponding parts, excuse me, of congruent triangles, then we want to name those corresponding parts in order, okay? All right, so we're going to look at some daily work on Unit 6.3, and we're going to be given reasons and a proof a good bit here. Remember, when we do reasons only, we take what we're given and we mark it in the diagram, and we write statements and reasons derived from the markings in the note section. C is the midpoint of AZ. Let's just look at that part. C is the midpoint of AZ. A midpoint is the point that divides a segment into two equal segments, but what we get out, which we're interested in, is the two equal segments. And so from that, we can conclude that AC is equal to ZC. We're trying to do corresponding parts in order. And the reason there would be definition of a midpoint. You can't say definition of unless you have the word and what you get out of it. So we need the word midpoint. So C is the midpoint, AZ and BQ. And the reason would be given. We haven't looked at the second part, so we'll look at that. It's also the midpoint of BQ, which means that BC is equal to QC. BC is equal to QC, reason given. So we took what we were given, we marked it on the diagram, we wrote statements and reasons derived from the markings in the note section. As we're thinking about congruency, we probably already see a side and a side, so we've got that on our mind. We're just giving reasons, so let's just follow that scenario. Remember, you look first in the given. So we would take this statement, we'd say, okay, is it in the given? Yes, it's in the given, so we put given. We take the next statement. It says AC is equal to ZC. We look in the given, and it's not there. So we don't go to the diagram, and it's marked. And if it's marked in the diagram, then we should have already put a reason in the note section, which is definition of definition of a midpoint. And then we go to the next given statement. It says angle ACB is equal to angle ZCQ. So we look in the given, and it's not there. So we go to the diagram. ACB is this one. I'm going to go ahead and mark it, equal ZCQ. And we identify in the diagram that those are vertical angles. And so we put vertical angles are equal. And this is why we look at the given first. If it's in the given, you don't want to go hunting for it when it's given. And the second thing, if it's in the diagram in the form of vertical angles are equal, or segment addition, or angle addition, or one of those things that's obvious from a diagram, you obviously don't want to go wading through statements above to try to figure it out when you're supposed to get it visually. So we go to the given first, the diagram second, and then the statements above. Okay? Now, you can see some things in that proof and right there, and we're going to just kind of leave you with that. Down here, when you look at naming on parallel, you got to go back in your mind and remember what possibilities there are. To prove that two lines are parallel, your choices are alternate interior angles are equal. Corresponding angles are equal. Same side interior angles are supplementary, or the transversal is perpendicular to both lines. Okay? Or definition of a parallelogram. So I didn't tell you which one of those it was, but when you think about how do you say something's parallel, your choices are alternate interior angles are equal, corresponding angles are equal, same side interior angles are supplementary. The transversal is perpendicular to both. Then we've got a theorem that says uh, if a segment that joins the midpoint of two sides of a triangle is parallel to the third side and its length is half the length of the third side, so there's another thing. A parallelogram has opposite sides parallel. If you could prove something was a parallelogram, then you could conclude then that it must have parallel sides because of the definition. So anyway, there's some of the options of number 7, but you can look at what you're given and what's going on here in the statements above and figure that out. Okay? All right. Number 2. As we think about ways to prove that triangles are congruent, number 4, you're going to be thinking about things like side, 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 angle, angle. Those are choices of how you would prove that two triangles are congruent. Once you know that two triangles are congruent, you then can say that the other parts of those congruent triangles are equal because corresponding parts of congruent triangles are equal. Corresponding parts of congruent triangles are equal. Okay? That's got lots of givens in it. And so we got some choices here. It's one of those. You got to choose the right one right here. Okay? Also, you're supposed to finish naming the congruency by naming the corresponding parts in order. So don't forget to do that. It's going to give you some equal sides, and you know to find an angle like AB, it says is equal to RP. If AB is equal to RP, then the angle opposite AB, which is angle C, would go with the angle opposite RP, which is X. If you first look at that, you might have the tendency to want to say that A is equal to R and B is equal to X and C is equal to P because they're top, top, left, left, bottom, right, right. But that's not the case. C goes with X. This picture's been flipped over because it was given that AB was equal to RP. So the sides opposite, the angles opposite those matching sides must be the matching angles. So don't forget to look opposite matching sides to find matching angles. And by matching, I mean corresponding parts of congruent triangles, okay? And then there's a couple of proofs here you're going to do by yourself, and then there's a little bit of extra math and some discovery learning. Let's just go through one entire proof again with you, just to kind of give you that encouragement. To do the entire proof, we would set it all up, write the given proof, put the statements on the left, reasons on the right, draw the diagram. Take what you're given, mark it on the diagram, write statements and reasons derived from the markings in the notes section. We're going to look at what we're trying to prove, make it the last statement in our proof, think of all the ways to prove that. Given diagram and statements above to eliminate as many ways as possible and figure out how we're going to prove it. We make the proof say what the method of proving it says. Once we think we're there, we check our statements and reasons from the bottom up. Okay, so we're going to start by taking what we're given, marking it in the diagram, and writing statements and reasons derived from the markings in the notes section. It says XY is parallel to FR. We show parallel errors. So we're going to write what we marked, x, y, is parallel to RF, reason given. And then we think, well, what can we get out of that? Well, out of parallel lines, we get alternate interior angles are equal, corresponding angles are equal, same side interior angles are supplementary. So we get that angle Y is equal to angle F. You can see that they make the letter Z, so they would be alternate interior angles. So we're going to say that angle Y is equal to angle F because alternate interior angles are equal. We also have a backwards Z in angle X and angle R. So we're going to mark that angle X is equal to angle R. Angle X equal angle R. Reason, alternate interior angles are equal. So what we have so far is an angle is equal to an angle. And then it says YQ bisects XR. YQ bisects XR. XR is the one that got bisected. The bisector of a segment divides a segment into two equal segments. So because of that, we can say that XQ is equal to RQ. I'm going to leave a little space. XQ is equal to RQ. Reason definition of the bisector of the segment. But before we can say definition of, we have to have the word and what we get out of it. And so we're going to put the word here, YQ bisects XR, reason given. What we see now is angle, side. Now, what we know to prove triangles are congruent by is side, 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 angle, side, and angle, side, angle. There, you can prove they're congruent by angle, side, but we haven't learned that yet. So we see angle, side, but we can't prove it by angle, side because we haven't learned that yet. We're limited today to side, 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 side angle, side, and angle, side, angle. So we need another set of angles, okay? Now, why am I even saying congruency? Because it's never even asked for that. Well, that's where our mind's at. We're in chapter 6, so we're thinking that, obviously. So that's all going through our head. So our mind is thinking out loud here. All right, so we wrote the given proof, put the statements on the left, reasons on the right, drew the diagram. We took what we were given, we marked it in the diagram, we wrote statements and reasons derived from the markings in the notes section. So now we're going to look at what we're trying to prove. We're going to make it the very last statement. When you get where you're going, there, right? That makes pretty good sense. We're trying to prove that XY is equal to RF. When we get there, we're done. So we need to prove that XY is equal to FR. Well, how are we going to do that? Well, we go through every way we've ever learned to prove that two segments are equal. Definition of a midpoint. XY and FR, no, they're not even attached. Definition of a bisector of a segment, no, they're not even attached. Addition, subtraction, multiplication, and division. Well, we don't have an algebraic equation set up, but we could add, subtract, multiply, or divide. So those are pretty well out. If two sides of one triangle equal if two angles of a triangle are equal, then the sides opposite those equal angles are equal. Well, those are not even in one triangle. They're in two separate triangles. Well, what about corresponding parts of congruent triangles are equal, what we just learned. Well, are those a part of two triangles that potentially could be congruent? Well, we got to know a lot of stuff about them. We've got so far two angles and a side, which could lead us to one of these two methods of proving it. And so we're saying, well, if I could prove that the triangles were congruent, then I could say that those two segments are equal because corresponding parts of congruent triangles are equal, and I can't get that on the board there. Corresponding parts of congruent triangles are equal. But before I said that they were equal because corresponding parts of congruent triangles are equal, I would have to know what? Well, I would need a statement that said that the triangles are congruent. So I would have to say that triangle, and I'm naming them, so I can name the first one however I want, x, y, q, is congruent to triangle. Now, if I'm going to call the first one x, y, q with x first, then I've got to call the second one r. X, it goes with r, see? And then I had y, and y goes with f, we know. So then q would go to q. But I would have to have a reason for naming them congruent, and my only choices are side, 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 side angle, side, and angle, side angle. So we took what we were given, we marked it in the diagram, we wrote statements and reasons derived from the markings in the notes section. We made what we were trying to prove the very last statement in the proof. We thought of every way to prove that. We looked at the given diagram and statements above and said, okay, it seems like we're going to be proving it by corresponding parts of congruent triangles are equal because none of the other stuff fit, and we already have some parts of those triangles which appear to be congruent. To do that, though, we would need to prove they're congruent first. So we abandon that reason. We say, okay, to prove this, we're going to move to the congruent triangles. Now we're trying to prove that they're congruent by one of these methods. We've got angle, side, angle, so we're leaning towards side, angle, side. If I was going to prove it by side, angle, side, here's my side, here's my very next angle, this would be my very next side. See, this is the side that went with that side. Here's the angle that went with that angle. To prove it by side, angle, side, I would need to know that AY is equal to FR. I can't prove that they're congruent because of that. I'm trying to prove that because they're congruent. We cannot conclude this at this time, so we cannot prove they're congruent by that method, which was side, angle, side. And so we check for side, angle, side, angle, excuse me. If we check for angle, side, angle, then we go ahead and keep the angles that were equal, you see. We have that this angle corresponds to this angle, and we've got that this side is equal to that side. If we're going to get angle, side, angle, then this would be the angle that we needed to see angle, side, angle. And so we would have angle, side, angle going this way on this one, and angle, side, angle going this way on that one. So if we could conclude that those two angles at Q were equal, we could say they're congruent by angle, side, angle. And we know that we can say that those two angles at Q are equal because they're vertical angles, and vertical angles are equal. So before we could say they were congruent by angle, side, angle, we needed to say that the two angles at Q which are angle XQY, and in the correct order, angle RQF, are equal. And again, we can say they're equal because they're vertical. And all of a sudden, we don't need something else to go with vertical angles, and it seems like we're finished with our proof. To say corresponding parts, we needed to know they were congruent with a reason. So we had to work for a reason, and we got it angle, side, angle. But to say that, we needed to know that the angles at Q were equal. So that opened up another reason to hunt for. And we got vertical angles, which is in the picture. And all of a sudden, we don't need any more statements to prove a certain reason. And so it looks like we're finished. So we check the statements and reasons from the bottom up. And I apologize that that got a little bit messy down there. But we were going to prove that they were equal because they were corresponding parts of congruent triangles. To do that, I need to say they're equal, and I need to know the triangles are congruent. So I need these two statements to make that reason. I have them, so that reason's justified. Its statement's justified, so we go to the next needed statement. The reason there is angle, side, angle. So I need to see that. Angle equal angle. Is that the right ones? X and R. No, I didn't even use that Y and R, did I? There's an angle side. You see, I used this angle, and I used this angle side angle here, and I used that angle side angle there. I didn't even use Y is equal to F. See that? So I don't even need this. I'm just going to throw that away. It's not a part of my proving it by angle side angle. So I put some extra stuff in my notes I didn't need. See, there's my angle. There's my, whoops. There's my side, and there's my angle. To prove they're congruent by angle, side, angle, I need to see angle equal angle, side equal side, angle equal angle. I have it, so that reason is justified, and so is its statement. So I go to the next needed statement. Angle equal angle, they're vertical. I can see that in the picture, that they're vertical. So that statement and reason is justified. I go to the next needed statement, my side equals side. My reason is definition of the bisector of a segment. If I'm going to say definition of, I need the word and the what you get out of it. We have the word and what you get out of it. So the reason definition of is justified. Therefore, its statement is justified. So we go to the next needed statement. I needed this to say bisector of. It's given, so that's justified. The next needed statement was my angle. I'm trying to keep it in the order. Angle, side, angle. I like that. My reasons alternate interior angles are equal. You cannot say alternate interior angles are equal unless you know the lines are parallel. So we need that statement to say that they're equal by alternate. We have it, so that's justified, and its statement's justified. The next needed statement was that they're parallel. That was given, so everything is justified. So we have everything we need. It's in the right order. So this is statement 1, reason 1, statement 2, reason 2, statement 3, reason 3, statement 4, reason 4, statement 5, reason 5, statement 6, reason 6, statement 7, reason 7. As you look in this, you can actually see that here's your angle, equal angle, side equals side, angle equal angle, and we proved they were congruent by angle, side, angle. Then we could say that the additional parts are equal because corresponding parts of congruent triangles are equal. Any questions on that? Okay. We're going to leave the other proof for you to do on your own. You'll need to move that from the note section to the proof, as you know. Little bit of word problem stuff here. Sam had one stick that was 1.5 feet long, a second stick 8.5 inches long, a third stick that was 6 3/8 inches long. What was the total length of the 3 sticks? Notice this one's measured in feet, this one's measured in inches, this one's measured in inches. What I would do is convert this to inches. and then add them all up, and then convert back to feet when you get that answer. And we've talked about dimensional analysis and all, so you should be able to handle that. Number 6, it says uh, if angle A is 60 and angle D is this, then find X. Angle A and angle D are corresponding parts of congruent triangles, therefore they're equal. So what angle A is and what angle D is are equal. Excuse me, angle A is equal to angle D. So what angle A is 60 is equal to what angle D is 4x plus 4. You've got an algebraic equation and you can solve, okay? And you can finish that. We're reaching conclusions. Again, we want you to draw accurately. Take this seriously. The conclusions are on the next page. We alluded to the fact that we were going to learn later that we could prove triangles are congruent by angle, angle, side. We already know side, 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 and angle, side, angle. So we're discovering with construction that angle, angle, side will work. And then we're going to discover that in a right triangle, hypotenuse leg will work. And again, those become the lessons for the next day.